just kind of free falling. You'll look what you feel abandoned.
How'd the homework out last night?
Yeah, you did. I missed out.
All right. So as you write down these notes, you'll notice we talked about this yesterday. If the functions don't follow the rule of there being a top and a bottom function, because think about it, we got that. Can you all agree? The foundation of this idea of area between curves was drawing in that rectangle that you're stacking from left to right yesterday. Everybody okay with that? You stack. I can't emphasize that enough because 7-3 tomorrow. The foundation of it is that you understand how the area is being calculated. It's not some magical formula. An integral is not some magical thing. It's literally the thinnest possible rectangles being stacked somehow. Well, the somehow yesterday was drawing them, the rectangles' heights are up and down. The bases are, what would you call the base using calculus terms? What would the base of every rectangle be if you're stacking them from A to B? What's the base of every rectangle? Because x going to 0 is literally an x value. What do we call this thing? What do we call the width of every rectangle? We built it up. What was the width of every rectangle? Half, fourth, eighth. What do we call that? The change in x, right? Wasn't it delta x for a while? And then if you have enough of them, it turned into a dx. And we kind of overlook that. I mean, we do this. We write this out, and sometimes it becomes some abstract like formula. It's not really. Look, it's a height times a base, right? I mean, just infinitely thin. It's a base times a height, and it's adding them all up from A to B. That right there tells you you're stacking rectangles vertically from left to right, doesn't it? Doesn't it? I need you to get this, okay? This right here tells me I'm stacking rectangles horizontally, but I'm going from C up to D. Now, if I do that, if I stack them from C to D, how do I get the heights of all those rectangles? Isn't it not top minus bottom? Now it's right minus left. Do you agree? So isn't f of y the greater function, the right function, and isn't g of y the left function or the lesser function? Or really, I'm using the word function. You guys know what I mean. Relation. Doesn't have to pass a brick line. So why do we have to do this? Well, because in this region, you can't do a top minus a bottom. A top minus bottom is not going to work. This is so important because once we start revolving these and create three-dimensional solids, if you understand the foundation here, it's going to make it so much easier. Okay, because there's going to be what's called the geometric cross-section method. There's going to be the disk method, the washer method, the shell method. Okay, and there's going to be some decisions that have to be made. And what method do I use? Well, it depends on the region. It depends on the region. How do you stack these things? First of all, how are you going to stack them? And then how are you going to create volume from it? Okay, it's a really cool application. Really cool. But we need to get this first. All right. Homework questions from last night. Are there any you'd like to see worked out, discussed? I know one of them ended up being with respect to y. I think number 3 was with respect to y, wasn't it? Did you have enough information to figure that one out, or was it kind of, were you confused? You plugged in x's? That's fine. That one was pretty easy to solve for. So did you have the cube root of x as the top function and the square root of x as the bottom function?
Whenever you plug it into
your calculator and you get like a negative, will that always just be positive?
It just means you called the wrong function, the top or bottom one. So go back. Don't leave it negative, and don't just put a plus there. I do check the setup, so go back, make sure you figure out, did I do some math wrong, or did I subtract? Did I call the wrong function the right or left or top or bottom? I think that worked out to be were they reversed? No, that should be. Wasn't it cube root of x minus square root of y or square root of x? And then the bounds were easy because the intersection points, the x's and y's were the same on both. It was 0, 0, and 1, 1, so you couldn't have gone wrong there. Okay. Just be careful. If you're going x's, you look at the x values of the points of intersection. If you're going y's, you go the y values of the points of intersection. But here they were the same. Any questions from the homework? Be honest. Done all right?
Yeah, number 17.
17? All right. And as soon as you read the directions there, it says find the area of the region enclosed. So all right, I can't decide top and bottom until I know where they cross, right? So let's find out where they intersect. So 7 minus 2x squared equals x squared plus 4. So we have 3x squared. What happened here? Okay. 3x squared. Yeah. Minus 3 equals 0. Double check. 3x squared. Minus 3 equals 0. Did you solve it that way? I thought there was an x term at first, so I was going to do trinomial factoring. This one's not so bad. So x squared equals, add 3, divide by 3, x squared equals 1. So square root both sides. What's the square root of x squared?
Plus or minus.
Yes. Plus or minus x. And the square root of 1 is just 1. So x equals plus or minus 1. Those are my intersection points. As soon as I see that, I'm going, okay, -1 to 1. And to decide top minus bottom, by the way, are we all okay? I'm doing top minus bottom because it's with respect to x, right? So there's a dx here, there's a top, there's a bottom. I'm going to plug in 0. 7 minus 0 is 7. 0 plus 4 is 4. This is the top function. Did you get that right? Okay. So 7 minus 2x squared minus x squared plus 4. Plug it in. Did anyone do these by hand? I did a little board last night. Had nothing to do. Like, the weather's nice, but I don't feel like going out. I'm going to do some calculus by hand. Nobody? Maybe? All right. Other questions? Answer was, it was at the back, but 4. Ooh, that was pretty. 4. For sure. All right. Moving on. Find the area of the region bounded by the curves x equals y squared minus 4. Can you guys see that in the back? Can you guys see the squared up there? Y squared minus 1. And y equals x plus 1. Little chin scratcher here, maybe? Maybe a little, What do you see is maybe a bit interesting? A bit, causes to be a bit pensive. There's a good word for you, pensive. What's the problem here? Chad?
X equals y squared minus 1.
What's an issue there?
The other one's y equals.
You have to make a decision, right? We have to make a decision here. Yeah. To integrate with respect to y or integrate with respect to x? Top minus bottom? Right minus left? That is the question. Do you know what the graphs look like? Sometimes the graphs, their appearance of the graphs, will tell you the best method. Let's do a quick sketch. All right. We'd like to solve for y. We'd like to graph for y. So y squared equals x plus 1. Agree? Agree? Square root both sides. What's the square root of y squared? Plus minus y equals the square root of x plus 1. So y equals plus or minus the square root of x plus 1. That's interesting. And this guy's already solved for y. That's easy to graph. So quick little sketch. All right. Do you guys know what the square root function looks like? Not plus or minus, but just the square root. We looked at it yesterday. What does it look like? Like an arm, right? Top half of a sideways parabola. This one's going to be the top and the bottom half of a sideways parabola. Whereas let's call it a vertex. Sideways parabola, it's going to have a vertex and go one way. Or like my favorite band, one direction, we could say. Okay. Too far. Just kidding. Madison, don't judge. Where's the vertex? That x plus 1 inside causes the vertex to be at x equals... Here, -1 or here 1? And who are my... I can never remember which one. I can never remember. Shifted right, shifted left. Who are my people? What causes it to be 0? Well, when x is -1, it causes y to be 0, doesn't it? That's the way I remember it. When x is -1, it causes y to be 0. Agree? Or if you're I just remember rules. It's opposite. Inside parentheses, opposite translation. The plus 1 causes it to move left 1. Okay? And it's the top half, and it's the bottom half. Y equals x plus 1. Well, it's easy. It's a line with a line intercept of 1. Now, I'm going to see, I'm kind of curious, I think you should be too. To get this drawing correct, we want to see, where does it pass through this sideways parabola? Is it right there? Is it down here? Because do you agree? I'm drawing this incorrect to make a point here. Do you agree? If I take this line and I put it right here, would the top minus bottom method be fine? Or do you not know? Be honest with me. Here's the question. Here's the question you should be asking. If I want to do top minus bottom, is the top function the whole way from left to right on the interval? Or does it change? Or is it not even possible? Well, if this, stay with me here, if this line passes through that sideways parabola at the vertex or above, is top minus bottom safe? Or can you not tell? Enhance. 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 All right. Top, bottom, top, bottom, top, bottom, top, bottom, top, bottom. Good? But what if it crosses there? Question? Ready? Top, bottom. Uh-oh. Uh-oh. That's not okay. Do you agree? Yes? Are you with me here? Be honest. Okay. So it really depends, okay? if that's the case, we don't want to do top minus bottom. We would need to do, ready? Right, left, right, left, right, left, right, left, right, left. Ooh, the right function and the left function stay the right and left the whole way from bottom up. That would be okay. You with me? Well, let's see. What are some values you might want to plug in to test? Let's find the x-intercept and the y-intercept of this one, right? What's the x-intercept of the line? Oh, come on, people. -1? Do you know how to find the x-intercept? -1. Ooh, okay. So the sideways parabola and the line cross at the sideways parabola's vertex. By the way, this is going to be done in the calculator, but you guys need practice with this, okay? Because it may come up on a test where you have to do this by hand. So we need to be able to do it both ways, all right? And we know where my drawing is not to scale. But what's the y-intercept of the line? 1. What's the y-intercept of this sideways parabola? 1 and -1, correct? 1 and negative. So technically, that's where they cross. They cross again on the y-axis, don't they? Okay? So, who are my top minus bottom people? Vote. Top minus bottom? Who are my right minus left people? They're both fine. Okay? This one's fine either way. Because the line didn't pass through the sideways parabola lower than the vertex, right? Not a problem. All right, if we're going to do a top minus bottom, we're using x bounds. I'm going to make this extra clear. Ooh, extra clear. So from x equals -1 to 0, good, of what's the top function? Make me proud, make me proud. Top function. Okay. Well, we're doing x's. We chose to do top minus bottom. Top minus bottom, we have to do x's. The x function. What's the x function top? What's the top one? Ooh, huh? Just positive square root of x plus 1, isn't it? The bottom half gets ignored. Okay, like the middle child. All right, it gets any middle children in here? Or my middle children? Do you get ignored? No? Oh, good.
I get ignored constantly.
Do you think that's what developed the Chad?
It has to be. It literally has to be.
Gotcha. I'm starting to understand a lot more. We'll have to have a coffee sometime. Talk about it.
Oh, okay.
You won't show up.
No.
That's Chad moves. All right. Radical x plus 1 minus. See, I'm getting it. I'm getting the whole chat, aren't I? Minus
X plus 1.
parentheses x plus 1. Are we good? Yes? Now, or could we do y bounds and do right minus left? dy, right? Left. Well, what would my y bounds be? What's my lowest rectangle I would draw sideways? What's the lowest rectangle? 0. What's the highest rectangle I would draw sideways? 1. What's my right function? X plus 1. What's my left function? Oops, I'm sorry. I need to change something. Caught myself. These need to be y's, don't they? So what is the x plus 1 function written in terms of y? X equals y minus 1. So we're going to put y minus 1 here. And then the left function relation, whatever, is y squared minus 1. Does that make sense? You could type those in. Honestly, I don't care about the number right now. The process is what I'm make sure you guys get. We're good? You guys can type stuff in. All right, we kind of talked about that one yesterday. It says using geometry. It's like calculating the too much and then taking off the triangle. We talked about that yesterday. All right. So I kind of wanted to talk about that one. We're gonna go over one of them from your homework. Let's do number 10 from your homework. So we're gonna have part of class today to work on this. Go ahead and write those down. Page 395, 10, 13, 16, 18, 22, 24. I kind of thought you guys would have more questions on the homework from last night, but we're good? All right. Don't forget, those multiple choice, 1 through 30, are due tomorrow. Who hasn't started them? Chads.
I'll start with
You guys had Monday and Tuesday were work days. You got most of it done, didn't you? Huh? But you didn't do any homework those nights, did you? I am not feeling great about this AP test.
Me either.
It's all right. You don't got to say it. I could have taken that's a right mind. Let's take it just here. Or just here for not actually.
I was like, what?
Do it. No, that's what we have said.
All right. Here's number 10. 10 was actually graphed for you in the book. In case you don't have your book with you, 10 is graphed for you. That green line is x plus y equals 2. That red curve is y equals x squared. We've got that yellow region we're going to calculate the area of. And I think it's pretty clear from the book that these functions intersect at y equals 1 and x equals 1. Let's vote. Who are my right minus left? Let's do top minus bottom first. Who are my top minus bottom people? Top minus bottom for life. Who are my right minus left people? Ooh, interesting. It looks like a little math battle is about to happen here. Why are you top minus bottom? Own it.
Because they're wrong.
Okay. Let's try it. Hang tight on writing anything down because we're going to compare the two methods and decide. We're going to compare the two methods and decide, so don't write anything down quite yet. All right, if I do top minus bottom, I've got x bounds. I've got x variables, and I've got a top minus a bottom. Ready? Draw in the rectangle. Ready? Top, bottom, top, bottom, top, bottom, top, bottom, top, bottom. What's the issue? You have to split them up. Why? Because from 0 to 1, the top function is the red. And then right here, the top switches to green. If a top or a bottom change on the interval, you got to break it up, don't you? You don't you? Well, if you're like, you know what, I've committed to top and bottom, I'm going to stick with it because I feel like the top minus the bottom just deserves it, okay? Deserves that commitment. Then you go from x equals 0 to 1, doing the top. What's the top function? Minus, what's the bottom function between 0 and 1? Top, bottom, top, bottom, top, bottom. 0. Plus the integral from 1 to 2. Ready? Top, bottom, top, bottom, top, bottom. What's the top function here? 2 minus x? Minus 0. That would work. That would work, wouldn't it? It's just the area under the red and then switch it over to the area under the green. Or, my right minus left, people? We go y equals something to y equals something. dy. Here we go. Do those blue lines bother you if I keep them there? Is it okay if I switch to purple? What are we going from? Always decide your bounds first so you can be careful when you do right minus left. What are my bounds? 0 to 1, aren't they? Y equals 0 is here. Here. Y equals 1 is here. Did I write that? Did I seriously write that? 0 to 1. And we're going to do a right minus a left. Are we going to need more than one integral? Let's see. Ready? Right, left, right, left, right, left, right, left, right, left, right, left. Would you look at that? One integral. Because the green is always the right function and the red's always the left function if on the interval we're stacking, right? Right function, careful, right function. Two minus y. 2 minus y. Left function. What do you think? Plus or minus the square root of y, but which one is it? Or is it both? Just plus, right? Minus the square root of y. I want to point something out really quick for you. Okay, I know what you guys struggle with now, like certain things you struggle with, and that's okay. I want to do this one more time. Ready? If y equals x squared, then isn't plus or minus x equal to radical y? Yes? Yes? We're not used to this. Guys, I need your attention whether you think you're good or not. I need your attention for a minute. Okay? You're going to see this a lot in the next two sections. Here's a quick way to decide. Some of you weren't too sure. If you plug in a y value, like 4, what's the square root of 4? 2. Is x positive 2 when y is 4, or is x negative 2 when y is 4? It's to the right. X's are positive over here. We want the positive x's. Do you see what I'm talking about? So if you're testing the plus or minus, okay, you're not seeing whether it's above the x-axis or below the x-axis. You're looking to see if it's to the right of the y-axis or to the left of the y-axis, whether x is positive or whether x is negative. Because what's this over here? X equals negative square root of y. Do you see it? So we have positive square root of y since it's over here. There's your integral. I will expect you to do the most efficient process. One integral if possible. Don't be lazy. Okay? Don't be lazy. Decide on the one integral setup. Okay, you guys are able to do that. Questions on this? There was one of your homework questions. Proceed. Class time to work on homework? Man, it's almost like you're going to have more time tonight to finish those multiple choice.
Wait,